Hello, welcome back to today's session. Today we will cover further studies about the shadows and also about solar studies. So today I will show you how we can create shading devices and how we can create shadow range diagrams and how we can prepare a sun path diagram for further studies of building form or even shading devices. So what I mean by that is we will be creating shadow range diagrams like this. Just a second. Okay, we will be creating shadow range diagrams. That means shadows of different time and different dates will be overlapped to create the effect. I mean, so that we can understand which part is receiving more shadows and which part is receiving more light for different time period. So we will create shadow range like this with the inside of SketchUp only. Then we will also try to create some kind of tentative as well as some detailed shading devices, and we will also create a sun path diagram like this. So in case you are not aware of sun path diagram, it is basically the path along which the sun moves throughout the day and throughout the year. So we are going to trace that path as well based on the geolocation of any particular region. So you can do that for any location of your choice. So here we have SketchUp. So I will first go to the geolocation and add a location. Let's stick with the same location where we had already been working on. So based on this geolocation, we will be working on our shadows. Okay, so let's import the model. We don't need the snapshot, so I will keep it, but I'll turn the layer off. Let's turn the layer off. Now you can see that this model is geolocated. Next up, I will create some basic form, building form. Okay. So let's create, let's have it in dimension. Let's create a building of 15 meters by 25 meters. Okay. And give it a height of 3 meters. Okay, let's say we have this building form. Okay, so we can turn on the shadow, and we also need to adjust the time zone to UTC plus 530, which is the Indian Standard Time Zone. And let's turn on the shadow, and we can pick up a date. Let's say we are designing for the equinox. So let's type in 0922. Okay. So this is the equinox for this location, and on this day for this time 1:30 we have this shadow, right? So let's say we have to provide shade for the facade, the entire facade which is facing the south. Okay, so for this day and all the day throughout summer. Okay, so we can also have it on March. So throughout the summer we want to have the shade. Okay. So let's have it on, let's type it 00. Now I will create a projection of, let's say, 150 and project it outward, and while keeping the shadow on, I am modeling it, right? So I can see the shadow as well. So let's say we have covered the entire facade with this projection. Okay, so now we can see that For the entire day, this facade is receiving the shade. That means excluding the morning and the evening, but almost throughout the day it is not receiving any sunlight, direct sunlight. So let's skip the time as noon only, and let's change the date. Now throughout the winter it is receiving the sun, and throughout the summer it is not receiving the sun. So that means from April till next September end, you don't see the direct sun on this facade, right? So this is how we can do a tentative or preliminary study of the projection, so that we have an idea about the shadows and the shades and the sun movement. Okay, so this is how we can do temporary or preliminary studies. And we can also go ahead, and if we want to prevent the summer sun, morning sun, then also we can create our shading devices, and we can prevent the sun from for the morning as well as even for the evening. Let's pick the same day, and if we want to prevent this sun which is at 3 o'clock, we can also prevent this by creating this kind of shading devices. Okay, so now you will see that for the entire day there will be no shadows. Now this is easier if we do this on the southern facade. Okay, so if we have to do it on a western facade, so how can we do that? Similarly, we can also create shading devices. Let's say we have this as our window. So let's have a glass window. So let's have an offset first, 150, and then we have the window. So we are doing a preliminary study, so we will be sticking with the horizontal, and vertical shading devices. Okay, so let's project this and see whether we can prevent the sun from coming. So we have some kind of prevention from this, and if we project this one, then there is no effect, right? So there is no point in projecting this. So let's say we need to project this facade. Okay, and we can model out with some experiments, and we will understand how we can model it on the western facade as well. Now you can see that the entire facade, almost the entire facade, is in shade. Okay, so for this we can also have some optimization along this direction. Okay, to have a better result. So we can model out, we can see the shadows while keeping the shadow on, and we can also have the shaded device design based on the shadows. Okay, so we will be proceeding to more accurate ones later on, but let's understand that we can do this study. So let's turn off the shadow. I have got a shortcut for num+, so if you have downloaded the references, so you will be able to turn the shadows on and off using the num+, that is this one. Okay, so let's now try to create a shadow range diagram for a building. Okay, so let's say we have a building. Let me try to create some mass and volume on it. Okay. So I'm going to convert this into a group. Let's erase all the unwanted lines first. Okay. So let's say we have a building form which is like this one. Okay, so make it into a group. So we will be creating the shadow range diagram for this object. Okay, so if you remember that we can create shadows and we can animate the shadows as well using the scenes and the animation tool. That is the scene transition. So for that, what I will do is first, let's pick the date. I will try to create the shadow range for the equinox again. 2203, and I will try to find out the sunrise. So if I pull this arrow all the way, then you can see that we have the time for the sunrise. Okay, so if I just move it to 1 minute forward, then we have the sunrise. So this is the point where we can pick with the sunrise. Okay, so next up is I'm going to save this sunrise as a scene. Okay, so I'm going to go for the plan view and go to output and make sure we have the right layout before we save the shadow settings. From here again we need to change the time 04 and sunrise 1 step forward. So the sunrise, we need to find the shadow. I think there is some missing. Okay, we have the geometry turned on again. Let's get rid of this only. Okay, now we have the sunrise at around 6 o'clock. Okay, so we will place our scene and I will create the scene. So next up, I need to find the sunset on the same day. So I will pull this all the way to the end and I will just reduce the time so that we can find it in a better way. So instead, I will keep this as 6 a.m. So I will put the next scene at 6 p.m. 6 p.m. Okay, so we have 13 different. We will have 13 set of shadows. Okay, so I will update this, add it to a new scene. So we have the morning and the evening sun. So let's rename this so that we recognize them. Evening. Now we need to turn on the animation for the scenes and also turn on the animation. So we have the animations turned on, and let's keep the camera also on for both the scenes so that we get the viewing angle also saved on it. Okay, so now animation, these scenes are included in the animation, but we need to turn on the animation setting also, transition setting. Now we have the transition setting also, and thus we can see that we have all the shadows available for this particular day, right? So next up, what we can do is we can, if we want to have shadows for individual time, we can create each and every scene for let's say for 7 a.m., then 8 a.m., 9 a.m., 10 a.m., and save them as individual files. But instead, we are going to do a little bit of smart work by exporting it as an animation. So by exporting it as an animation, we will get all the scenes that are in between. So I'm going to go to File, Export as an animation. Okay, so let's pick up the folder where we want to save it. Call this shadow range. Okay. Go inside this, and we are not going to save it as an MP4 or a video format. Instead, we are going to save it as PNG or JPG. Okay, so now this is important. Now since we have I will have to show this. If we have 2 seconds for the scene transition, and depending on that we will have to set our number of frames. So I will have 1 second for scene transition so that it is easier to calculate, and export the animation in the same folder, shadow range, and here. So we know that we have 13 we have 13 hours, right? So I will type in 13 here, and make sure loop to start is off and anti-aliasing and this can be on. Okay, so we can also specify the resolution. Let's have it on the HD resolution only. So you can specify it manually also by going to custom. But this is important. This frame rate is important, that it should correspond to the hours for which we are creating this. Okay, so let's save them. It's going to save each and every scene and 2 extra scenes for the starting and the end. So we have the shadow range. Exported is it as a image. We should export it as an image. Okay. Again, everything will be the same. Export. Don't need this. So you can see that we have now all the scenes we needed for the shadow range. Now we don't need this, and rest we have the hourly division for the shadows. Okay, so next up what we need to do is merge them all using a photo editing software like Photoshop and create an effect like this one. Okay, so let me quickly open Photoshop and demonstrate this, what I mean, how we can edit it. Let's open up Photoshop. This is basically a study of the shadows, and we can export the shadows for different time as well as for different days. We can also have them all together. Now we can put them all onto one file, single file, and overlap them. I'm holding the shift key so that we overlap it on the same location. This is the file. So you can overlap, copy them all onto different layers and select all the layer and convert them to multiply, and you will get this kind of effect. And with a little bit of tweaking with the opacity, you will get the proper way to represent the shadow range. Yes, so I hope you understood this. You can overlap all of them onto one image and play with the opacity, play with the layer filters, and you will get the shadow range diagram exactly like the one I had shown, which is this. So this is the shadow range. This shadow range diagram was created in SketchUp only. Okay, so you can also play around with different dates. You can create shadow range for equinox, summer solstice, and winter solstice. So next up is creating a sun path diagram for this particular location. So I'll come back to our working style. So let's get rid of this. So we can start with a new file, or we can start with a blank file. So it is recommended if you use a blank file for creating shadow range diagram, and make sure you have the file geolocated to the right location. And now we are going to create a sun path diagram. So for that, sun path diagram is this. Basically, I have already explained the path for the movement of the sun. Okay. So for that, we are going to create a circle. Let's increase the number of segments to 64 so that we have a better circle. And I can input any radius. So let's have a radius of 20,000. It depends on how large or how small you want to create the sun path. Okay, so we have the circle for the base. Then I will create a vertical line of the same radius, 20,000. I mean this of the radius, same dimension as the radius, so that you can see have this. Okay. Let's reverse the face. Now let's turn on the shadow. Now we don't see the shadow from edges by default, so let's turn on the shadow from edges. Now you can see the shadow from this edge. Now we are focusing on 3 different dates, that is the summer solstice, winter solstice, and the equinox. Summer, winter, and equinox. Only those 3 we will be creating. Okay. So, and we will create it in 3D. So we have the time zone fixed. So now I'm going to go for the summer solstice 21. This is the okay. We have the summer solstice. Now we need to identify from where the sun is rising. So we have the sunrise point at the extreme edge of the bar. So this is the direction of the sunrise, right? I mean, it's the shadow of the sunrise. The sunrise direction will be opposite to that. So I will draw a line to trace the angle of the sun, right? So I can be as far as possible. The further, the better. So we have this line. So I'm going to copy this. Make sure to copy it because we have got interference with the object. So I have copied this. So now we know that this is the direction of the sun at sunrise on the summer solstice. Okay, so this we have got the direction, right? So let's draw the direction for the sunset. So if you don't see that shadow, you just need to change the time minute by minute and you will get the shadow. So let's trace this line along the shadow. You can zoom in to pick the point a little bit more accurately, and erase this. Move this to the other side. Copy it, in fact, not move it, and you will have the direction of the sun at sunset. Okay. So next up is we need to find the local apparent noon. So local apparent noon is nothing but the time when the shadow is shortest on that particular day. Okay, so we will try to find it at around noon. So let's change this time. So it may not be exactly at 12 noon, depending on the latitude and longitude, but let's see at what time it is crossing the green axis. So at around 12:20:22, it's between 12:22 and 12:23, right? So we take 12:22 as our point because we don't have the second here. So we know that the shadow is shortest at 12:20:22, and we need to pick the length of this shadow, but don't pick the direction. Okay, so we need to pick the length of the shadow along the green axis. Make sure you pick it along the green axis only, and connect this point to the height of the line. So now what we have is the direction of the sun at noon and its altitude angle. Okay, so this is the altitude angle, and let's move this to the other side, and let's erase the line for the shadow length. We need to move copy it to the other side. So what I mean by this is the sun will rise from this angle at this point and set at this point, and at noon the sun will be at this point. Okay, so at around this point, basically at along this angle. So for that we need to trim this line along the sphere basically. So let's draw a circle along the red axis so that we can trim the line. We have this circle, and now we can trim the line, and we have the point for the sun. Okay, so now we have 3 points, so we can draw an arc to define the entire sun path. So I can draw an arc from this point to the other point. Make sure you pick the point correctly. We have this point, okay, and the point for the sunset at here. And next up, we need to change the segments. So let's change the segment. First I'll change the segment and then I'll draw the arc. So let's change the segment to 32. Sunset, sunrise, sunset, and the arc will be here. Thus we have the sun path for this particular day, for the summer solstice. I hope this is clear with everyone, and I am guessing that you all are familiar with the concept of sun path and how and why we need sun path. Or is anyone confused regarding this? No? Okay. Now we can repeat this process for the summer, for the equinox as well as for the winter solstice. So I'm going to demonstrate this for the winter solstice, and you can create it in the same way for the summer solstice as well, for any location of your choice. Okay. So let me first move these lines to a new layer. I'm going to create this as a group first and move the group to a layer which I will call summer. I'm going to create a layer, new layer. I'm going to name this as summer. Okay, and I have turned it off, and we don't need these lines anymore. So, but we need the vertical line. So next up, I'm going to do this, repeat the same process for the winter solstice, which will be 21st of December, and I need to find the sunrise. So if it is totally black, then I will increase the time by 1 minute. We will see the sunrise direction. Pick the point, pick the direction, copy the line without changing the direction to the other side so that we get the direction of sunrise, erase all the unwanted lines, unwanted part of the lines, and we have the direction for the sunrise. Similarly for the sunset, I'm going to drag this all the way to the other side. We have the sunset direction, so pick the sunset direction along this, and we have the line, the direction, and move the object or the line, copy it to the other side of the line and remove the unnecessary lines, and we have the direction of sun at sunset. So similarly, we will be finding the local apparent moon at around 12 o'clock. So it is 12:20 to, okay, it seems accurate more or less. At around 12:19, okay, 12:19, we have the local apparent noon. So let's measure the length and find the altitude angle along the green axis. Here I'm going to pick the length slightly smaller, because if we go more accurate, then this will be smaller, and pick up this point. Okay, so we had measured the length of the shadow at the local apparent noon, and we had also got the altitude angle for that, for the winter solstice. Okay, so I'm going to copy this line to the center so that we can have the angle from the center, okay, and it is the unwanted line. So next up, what we need to do is, again, similarly, we need to trim this to the sphere. So for that, I'm going to draw a circle of the same radius and trim the line here. Okay, so we have trimmed it, and we don't need this. We don't need the circle anymore. So now we have got the position of the sun at noon as well. So we have the 3 points on our solar sun path, and we can trace the path from this point to the other point. So let's pick the point for the sunrise and the sunset and the noon. So thus we have the sun path for the winter solstice as well. So I'm going to select all these lines, make it into a group, and add it to a layer, which I'm going to call winter, and make it invisible. And similarly, we can also create the sun path for the equinox. Now let me turn on both the sun paths and see how we can cross check it, and with reference to the location. Okay, so whether it is correct or not. So let's turn on both the files. So we don't have the angle in this case. I think anyways, we don't have the angle. It will be somewhere. Let's draw the circle first. So at this intersection, we will have the angle of the line for the summer. Let's move this inside the summer group. Okay, now in order to cross check, we need to go to a side elevation. So let's go to the side elevation, and you can see that these two lines are parallel. So excluding the error for the drafting, if we have missed any points or something, so these lines will be parallel. And if we try and measure this angle, so if we try to measure this angle, so this angle should be equal to the latitude of the location. So we have the angle as 61.7. So let's check the angle for the latitude. Okay, so 90 minus this basically. So this is 28.5. So in fact, from the vertical, I should have measured this angle. So if we measured this angle, so this is saying 28.9. So this is 28.7. So if I go to this, it is 28.5. So it is more or less accurate. Again, let's go to the side elevation and measure this one also. From the vertical axis to this direction, it's 28.5. So this one is more accurate than the winter. angle, and all the three will be parallel to each other. So if you draw them properly, accurately, all the three of them will have the angle same as the latitude of that location. So I guess you all have understood the concept and how we can draw the sun path diagram. Next up, I'm going to show how we can create a projection accurate to a particular sun path, or accurate to a particular angle of the sun. So let's say the sun path will be, let's try to draw an angle for the equinox as well. So let's say this is the angle for the equinox. So I'm just assuming it. So we have the equinox as well here. So I'm going to create a building block. Let's say we have a building like this. Convert this into a tube first. Okay, now move it to the center. Okay, now if I need to protect this face of the building for any particular day, let's say we want to protect it for the longest day of the year. So now for this location, this face will receive the sun throughout the year, because we know that it is receiving the summer sun, because you can see the angle is at an inclination. It is receiving the equinox sun, and it is also receiving the sun from the winter solstice. Now we want to block it for the summer solstice. Now for that we can have a projection. Yes, so let's draw a line and try to create a shading device, and let's project it up to the line for the summer solstice. Okay, so I'm going to change the time to the summer solstice, 06:21. Okay, now you can see that for this day at noon, this much of the projection is protecting the entire wall, right? So if I reduce it even by a little bit, some part of the building will start receiving the building. So this is how we can create accurate sun paths. So you can see the shadow is exactly, or at least 90% accurate to the height of the entire building. So this is how we create accurate sun paths. So let's say we want to protect the sun, the building from throughout summer, and we want to allow the winter sun. So in India, normally we design it to prevent the sun from summer and allow the winter sun. So as a thumb rule, what we do is we prevent the sun throughout summer from the two equinoxes. Okay, so let's draw the projection up to the equinox line. So this is just a tentative one, because we had not yet created the equinox line, right? So let's say we have this on the equinox. So in that case, if I shift this to the equinox, and let's say 22nd of March, we have the shade, and throughout summer we have the shade, we don't receive the sunlight, and post 23rd of September, which is the next equinox, it will start allowing the sunlight. So throughout winter, that is for the month of October, November and December, and even January and February, you can see that we are allowing the sunlight to enter at least to reach this wall. So we can also include openings and plan openings accordingly. So this software does not gives us the design of the projections, but if you know the method how to design the projections based on the direction of sun and when you want to protect it, then you can design it accordingly. And you can also design and use the same process to prevent the sun from for the other angles and for different times as well. So let's say we have this we are receiving the sun from an afternoon time, so we can draw the line for the afternoon, and based on this line we can start modeling our building. So we can not only just project the faces, we can even create modifications to the building form to create the similar effect. So let's say we have projections till here, till this point. So this projection will also affect the building the same way as if we have the shading device. Okay, so the building form can be designed such a way that it prevents the harsh sunlight and allow the welcome the more comfortable sunlight throughout the winter. And you can play around and derive any form based on these studies, and the only thing is you have to do the designing part manually, unlike other softwares where you will be given the design of the shading devices or the projections with the help of some calculations and inputs. But I guess this is more flexible if you are willing to design your own projections. So this will be all. I will be sharing further detail on this if you like to learn more on this. But you can try out designing your projections, developing your building form, and I request you to create your own sun path diagram as an assignment, and please show it to me in the next class. So tomorrow I will be expecting you, all of you, to create your sun path for a location of your own choice and show it on screen so that we can cross-check whether it's correct or not. Okay, and you can also try designing your own building form or projections based on the solar study. How to do it on other faces. So Vibhavadi is asking how we can create projections on other edges. Okay, so for that we need to draw the line. Let's say we need to draw the sun path for a particular afternoon time. So we can pick the time from the this time window. I'm not going to go to the go to create it that accurately, but if you understand the concept, the basic concept is you can get the angle from the sun path diagram if we have the shadow direction, and you can find out the angle of the sun as well, and you will also find the altitude of the sun because we already have the path, right? So once we have that angle, you can design it for this angle of the sun, right? So let's say we have to prevent the sun for this angle, right? So I will create some kind of projection that will go to this point. From the back. Okay, so I will create a projection from this to this point, and if we have this projection in our building, then the sun for this angle will be blocked. So if I change the time for 20:06 and 21, and let's say at around 2 o'clock, we're designing it for 2 o'clock. Okay, so if the sun is coming at 2 o'clock from this direction, then this projection will prevent the vertical sun, and if you want to prevent the horizontal sun, you can also use the same technique to prevent the horizontal sun if it is coming at an angle in plan direction. So the same technique can be used, so you just need to be a little more creative to prevent and protect the sun from prevent the building from the harsh sun. Okay. You can try it out. You will understand once you try it by yourself. So that will be all for today. So if you have anything else to ask, please, you can. In fact, if you have anything from the previous sessions as well, you can ask. Can you show Compost Swapper again? Okay. Let's turn off the shadow. Okay, by the way, unless you are designing for the shadow, please don't keep your shadows on, because shadows tend to slow down the system. So let's have a component. So one can be a 2D component or a 3D component. Let's say we have a 2D component. Let's create this as a component G. And we need to specify the center. Set component axis at the center. And I'm not going to name it for now. Okay, so we have one component. Now let's say we have another component of a different type. Make it into a component. And I'm going to change the component axis again. I'm going to place it somewhere in the center. And create. Okay. So I'm going to replace this with this object. Okay. So let's say we have different copies of this component, and even in different scale. One is smaller, one is larger, but those are all of the same component, copies of the same components. So I need to go to Compost Swapper first. Compost Swapper. Click on this. Now it is giving me instructions at the bottom that press Alt to select source component. Okay, so I'm going to hold Alt and click on the source component. So this will be the source which I'm going to place everywhere. So once I'm done, I can go on clicking, or I can hold Control and click once to replace all instances of the component. Okay, so you can see that all of them got replaced at once. Okay. So Compost Swapper, pick the source object. So source can be any object, any component. Just make sure you hold Alt and click on the source, and you can go on clicking those components which you want to replace, or click Alt and click. I hope it's clear now, Bhavadi. Okay. Okay then. Thank you all. I'll see you tomorrow at the same time.